Okay. And then I made a mistake in the notes from before. When I say inverse, you say shh. When I say inverse, you say what? Switch X and what? So I just did this stupid little thing. It told this, I just made up something like y equals 5 raised to the x, and I didn't put a value out in front. Fumble. Did you see that? Um, goodness. Okay. All right. When I say inverse, you say. So here's the inverse in green. X equals 5 to the y. Right? And then how do I get y isolated again? The glory and power of logarithms. As a matter of fact, remember this? Is this R? Oh, here it is. Remember I showed you this, but did I show you this yesterday? Did I? Did I? How come it's not working? There we go. Works on the video. Some people look angry right now. You should see the ABers. They really give me dirty looks.
What a logarithm is. The word log comes in and everything changes position.
And I think we can only have to see this once. That's it. All right, that's it. Okay, good. Get out of that. And then, yep, that was my noise. But you probably couldn't hear that on the video. It's on the calendar. So, the glory and power of logarithms, when I put the word log in front of this, what's the base? 5. What's next that I write? X. Of answer equals what? Y. The exponent. That's what I was trying to spit out there. So that represents the introduction to logarithms when I did that 2 days ago. All right, and then I'm going to show you another rule and bring back those 2 days ago's notes that I pulled out from my olden days that I told you about ahead of time, I thought. But anyway, look at this. How do I know this is exponential? Look at 1, 3, 5, 7. Those are equal input interval values. And when I look at the outputs, they have a common what? Common what? Ratio. There's a common R. Now the R is not necessarily equal to, because for every two x's, the common ratio is 2. So I had to do something to figure that out. But that is an exponential. That's what happens with this. When I say inverse, you say, look at the other chart. What's the other chart? Isn't that just a flip of the x's and the y's? So how do I recognize a logarithmic? Equal output intervals. You see a common ratio in the inputs, because when I say inverse, you say switch x and y. So that relationship is switched, right? Isn't that a good way of saying that? Okay, so now look at these three charts and tell me what you think. I'll let you look at them, and then we'll go 3, 2, 1 on A, B, and C. I screwed up B. I just looked at it too fast. Okay, so what's A? Is that exponential, logarithmic, or neither? 3, 2, 1, go. Exponential, because for equal input intervals, I have a common ratio. And these do go by 1, so what is that common R? What is that common ratio? Or B value, if you will. What is it? 1/2, and no one's answering? Okay. All right, what's the next one? Exponential, logarithmic, or neither? 3, 2, 1, go. Neither. Why? What are these? These have a common ratio, but wait a minute. These have a common ratio. That's wild. Right? So something weird's going on there. Something that doesn't represent logarithmic or exponential. And then this is a little weird, but what's the last one? 3, 2, 1, go. No one looked at that one yet? We'll wait. There's got to be something. Is this an AB class? Oh, because nobody answered the question. Like first hour. Can I tell you about first hour? Has anyone heard about it? I actually crawled on the floor in a ball because of stress. I made a mistake. I didn't crawl in the corner and crawl in a ball. But I should do it now, and you should take a picture of me and make it a meme. Because the problem was, this is what happened. We had a question that this kind of factoring came up, and no one's like, hey, how do we factor this? Everyone's like, yeah. I'm like, okay, what is the most basic type of factoring that starts with the G? Don't answer. It still took 2 minutes, and everyone's like, I've never heard of this. You've never taught me this. I'm going to call my lawyer. You've never showed me this. What is the answer, everybody? Greatest common factor. It was so funny. One girl, I feel bad for her. She goes, grouping? It's like, no, no. Thanks for answering, but no. GCF. So I crawled in a floor, in a ball, and nearly cried. Anyway, so I just use that as a delay. What's the last one? 3, 2, 1, go. It is logarithm, even though these go down by 3 and equal. So there is some sort of ratio going on with the x's. So when the ratio is in the x's, that's a logarithmic. All right. So it is weird. Hyde, thanks for listening. You guys are my psychiatrists because I'm too cheap to pay for one anyway. So I just use my students. All right. Anyway. Okay. All right. You remember this from our inverse section, right? F of g of x and g of f of x equals x. Now I was afraid that I had the teacher. I do. So I'll shut up for a second. But let's actually, and I don't know what this all is, but I'm just going to do their notes. All right. And we're going to do 2a. But this is good. So how do I find the inverse of a logarithm? You just do your stuff. You do your math that you know. But the first thing I have to do is 4 times. That doesn't belong there. So we got to divide by 4. Oh, wrong. I'm sorry. When I say inverse, you say I'm out of order here. You're out of order, sir. Okay, log base. And this is good. This is good. This is good. I'm really trying to make my G's not look like 6s. So I got to really watch out. That literally did happen back in the past. What's LO6? After 2 weeks of doing logarithms. Oh, teaching. Divide by 4, divide by 4. Okay, now we can do this. Remember the video I forced you to watch and made some people angry? Base, exponent. Ooh, let's use that puke color right there. Sorry, I mean the pink. Answer. Now turn that into an exponent. So what do I write first? What's first? 625 raised to the what? X over 4 equals what? Y. There's the inverse. Okay, so when I say inverse, you say switch x and y, and then you got to resolve for y. The only way you could solve an exponential exponent in the variable is logarithms. Wait a minute. I go to the multiple choice and I don't see this answer. I always like playing that game. So I go to multiple choice and I don't see this, but I see some other weird answers. So all right, I got to do something else. Like, oh, I remember that alternative form thing. And isn't this the same as 625 to the 1/4 raised to the x? Good Foiler, say it. This has nothing to do with that. The point of, wait a minute, is this right? What am I supposed to do with those exponents? Multiply them, and you know how to multiply fractions, I hope, with the x over 4. I'm lamenting because the fractions just blow some people's minds. We won't mention who. What's the 625 raised to the 4th now, everyone? 3, 2, 1, go. 5. You don't know that. I think we had some of those evaluations or thinking yesterday or the last couple days. We were bringing some numbers up to some big powers. Remember that one? Write 4 different ways of getting 4 as an answer. That should have been one of your 4. 5 to the 4th. Okay. Now, let these two, and then show through our composition of functions that we can do this. I got to show you something, though, before I, just throw something at you here. We know this is the case. So f of g of x log base 3 of x, okay? Right? So you input the value of its function for its name. That's what we got there. So I'll highlight that in yellow. And then I'll keep this in yellow. F of x equals 3 raised to the x. So then this is 3 raised to the x. No, it's 3 raised to the log base 3 of x. And then what am I supposed to get out of this? What am I supposed to get out of this if they are truly inverses? What am I supposed to get? X. Well, I'm gonna go to the old notes because it makes me happy. Wrong. Sorry. There we go. There's my there are 2 faces of Mr. Oh, poor people. All right. Then let's go here. Remember when I showed you this and I just was happy to see my old notes and they were still there. And remember I showed you some of these green boxes. Did I show you this? Right. All right. And then I don't think I wrote in this one. Good. Okay. And then I taught that common logarithms are log base 10, but you won't see them at your calculator. Right. We're actually going to go to the calculator and do this real quick. But then there's this one. 10, our old book, the only thing it was bad at is like showing exponents real good. Raised to the log of x. What's that based on that logarithm, by the way? What's the base on that logarithm? 10. So 10 raised to the log base 10 of x. Look at what they say. They say it equals x. I don't get that. So here's what I did. Back in the day, this is what I would do with the people. I'd say, okay, let's make this 10 raised to the log base 10 of x, and then set this equal to, I don't know, a new made up variable question mark. How do I know that equals x? I don't. So let me see what happens when I do this. By the way, this is actually an exponential format. What is this called? That's the base. Everyone else should be able to answer this now. What is this then? What position is that? That's the exponent. I know we have a logarithm, but it really is in exponential form. Big yawn. And then what's this? Answer. I just made that position up like I didn't know. So then I said, you know what? Change this to a logarithm. Log. I'm trying to get real fancy with my G's. All right. Log base. Who's the base? Who's the base? 10 of who? Of who? Question mark equals, well, look at the exponent. Log base 10 of x. I could have Lexi Samulus coming in right now from 4 years ago. So she's a freshman in high school. Minus 4, 5th grade? She could tell me what question mark equals. What's question mark equal? X. It's just a matching. I don't even have to know what LO6 is. All right. I know question mark equals X. Don't even need to know that. Okay. So that's it. And then what I showed the other class, and they just, yawn like that guy back there. All right. Clear. 10. Why do I have to pick 10? Because I don't have a log base 3 button, right? I have a log base 10 button. Carrots, delicious. Did you hear about those carrots that had some, what is it, salmonella in them or something? But no, what was it? E. coli? Oh, not good. I checked out my dog to make sure he was okay. All right. And then, you know what? 3,461. That's my favorite number. Whoa. Why did I pick that weird number? Because it's log 10 raised to the log base 10 of x. It doesn't matter what's in that position. Got it? Hey, you want to see something else fancy? Find yourself, Mr. Samulus. Raised to the ln. Why? What's ln? Log base what? And if you don't know that, severely and totally behind. I don't know what you're doing, right? 987-654-321. What's the answer? 987-654-321. Okay, just a point. It doesn't matter what's up in there. If it's x, then it's just x is the answer. So it has to be log base 3, for a 3 being the base. 3 to the log base 3, 7 to the log base 7 for this rule to actually work. All right, and you guys memorize stuff pretty good. So yes, that's true. And then the other one is not as bad. I thought it was, but it kind of is. I can go back to my blue chart. They are blue. G of f of x is 3 to the x. And then that becomes, go to the g function and plug in an x where that is. So that becomes log base 3 of 3 raised to the x. You know, and I can kind of cheat. I can. And look at this chart. It's really this one. You know, log base 10 of 10 to any power is that power, right? Log base 10 of 10 to the 20th is 20. Log base 10 of 10 to the x is x. So it really is that rule. I was worried there is another rule that we're going to learn after break about pulling this exponent out in front. I'm like, wait, they don't know that yet. Well, wait, they do. They should know that that turns into x. Okay? They should know that. Okay? All right, so that's proof that they are inverses. Okay, then all this is why we're going to be done by the second bell. I think you know concavity, right? I think you know increasing, decreasing, yes? What I can do is prove why this is a logarithmic function, although I think we've kind of really done this already. Input, say it. Remember you said that? Your last quiz or one of the quizzes, input, output, got you all the multiple choice correct. And it wasn't input, output, but it's a save, all right? It's always a save. And that's why I tell you, if I don't know how to graph something, just plug in a couple points and then maybe something will kick in what you're supposed to have memorized. Okay, let's just make this A1 for right now, and then B base 2, just to make the input outputs easy. I always like starting with this one to graph an input output. And then this is why this happens, X, Y. So if I just use this as where B is greater than 1 as an example, why is this the first point I'm going to plug in? What's log base 2 of 1? What's log base 2 of 1? 2 to what power equals 1? That's why this is the most important point of a logarithm. Where does that point go? We want to know that. What's the most important point for an exponential? Easy for me to say, 0, comma 1, the 0 power number. Right? Now it's 1, 0 because it's just flipped. Next one, 2. What's log base 2 of 2? 1. So 2 comma 1. Let's go crazy. Let's go like to 8 or 16. I think I went to that. You do 4 next, then 8, and then 6. Don't worry, I'll be done soon. All right. What's log base 2 of 16? What's the answer to that? What's log base 2 of 16? 4. 4 times 1 is 4. So way out 16 comma 4. This is very slowly doing this. You know what else you should plug in? A half and a fourth. And then that'll explain what's going on to the left of 1 comma 0. What's log base 2 of a half? 3, 2, 1, go. You know your negative exponent rule. What's log base 2 of a fourth? Because 2 to the negative second is 1 over 2 squared, which is 1 over 4 if you still don't know what you're doing. All right, 1/4 comma negative 2, I get it. So that's why this is happening. So what do I have here? An asymptote, because I cannot plug in 0 and look at the behavior as I get closer to it. I didn't even go very far. I only went to 1/4. All right, and then I'm mad about this. We used to do logarithms where the base was between 0 and 1, just like we did exponentials where the base was between 0 and 1. But I think the AP don't, so I think we're going to ignore it. Input, say it. You'd be able to graph log base 1/2 of x. Don't write it. You know what you'd plug in though first? What would you plug in first? Well, I'd plug in 1 still, because though it's 1/2 to the first power. No, what's 1/2? Sorry, what's log base 1/2 of 1? 1/2 to what power is 1? That's what I meant to say. 0, and then I'd plug in a half. What's log base half of a half? 1. Then I plug in a fourth. What's log base half of a fourth? 2. And then you'd still get this looking picture if you imagine those points. You would. So I don't know why they ignore that. I don't know why the APs don't hold you. And I think we went a little too, let's only do what AP does, but whatever. What this one is y equals -1 times log. Oh, let's just mix it up and say log base 3 of x, just to play with different numbers. I've already bored them, so let's just move on. 1. What's 1 comma? 1 comma what? 3, 2, 1, go. 0 still, even though there's a negative, same point. And then not 2, but 3. What's log base 3 of 3? 1 times negative 1, no. Flipped it upside down. And then 1/3. What's log base 3 of a third? Negative 1. But negative 1 times negative 1 is what? 1. So it should be those points alone that kind of get your shape as long as you have some knowledge of what's happening here. Okay? And some knowledge of these asymptotes. Got it? So I don't think I have to waste time with you on increasing, decreasing, concave up, down, end behavior, right? You know how to do all that? So when we look at this, what is, and I'm sad I have to write all these limits, but that's okay. It's okay. We're apparently showing we have an asymptote here because it's a logarithm. What's x0 plus limit? What's the answer to that? Input, output. Remember what this means. My honor or regular students don't really understand this enough, I think. This means I'm plugging, what happens when I plug in that number? What am I getting? Well, 0.00000 whatever 1 is like right there, comma. There's my Y finger. Input, say it. I don't know how I have people in my AD class that still don't know how to do this. It drives that I want to crawl in a corner again. What's the answer? Negative infinity. Some have missed every single one of these all year long. I think they're just going for the record. I'm going for 100%. All right, and then what happens when I go to the right? Limit of f of x as x approaches infinity. What's the answer to that? Very slowly, but what is it going to go to? Infinity. Okay, and then this is the same, but you know what? Let's just take this limit and let's be fast with it. Don't be lazy on tests. What's the answer as you go 0 plus here? Where's the graph going to? And then where's the where are we going as we go to the right? Okay, that's negative infinity on the flip. Now this one input, I am going to do this real quick, and it's only going to be 3 points as long as you get the idea and you do. That's why it's refreshing. I thought it was supposed to rain all day today. Good. What would I plug in? Can I plug in 0? And that's what we really want to search for is the 0 value. What happens at 0? What's log base 3 of 0? Undies. So means this is where your asymptote is. But then what am I allowed to plug in next? 1? No. 3? No. What do I have to plug in? Negative 1. Why? What's log base 3 of negative 1? 0. What's 0 times 2? So what happened here? I have a y-axis reflection. And we should know that from the thing in there. All right, and then negative 3. What's negative 3? What's log base 3 of negative 3? 1. What's 1 times 2? 2. So this should be enough. Negative 3, comma 2, and then, got it. I know it's happening already. But what I want to do is negative 1/3 just to prove it. What's log base 3 of negative 1/3? Log base 3 of a third, which is negative 1 times 2. No one's answering questions anymore. They've checked out. Negative 1/3, comma negative 2. That's enough. I get it. We'll write these limits because we're on a video. You know what the left side is, though? The limit of f of x as x does go to negative infinity. What's the answer? Infinity this time. Well, not this time. Maybe that's what's happening as I plug this in. This is rising. I just don't know how we can be missing these. There's just some sort of disconnection. There's something crazy going on. Really is. And then 0 to the left, right? What's the answer to that? Negative infinity. You get it at this point. It's that part of the graph. That's when you're just left with 0. You still are bamboozled by that. Okay, and then I honestly did not even do this one last hour. I know what they're trying to do. They're trying to do an extrapolation. I'm just going to get to the brass tacks of it. What are we doing here? Are we increasing or decreasing in this exponential scenario? What are we doing? 2, 3, 6, 20, right? And then do you know how to find average rate of change? It's just what? Slow. Now what they want you to do is find the logarithmic inverse of this. That just means 3 comma 2, right? 27 comma 6, right? And then 81 comma 8, right? What's that doing? Is that increasing or decreasing? Increasing or decreasing? Oh, 3, 27, 81. I'm still going up for the x's. What are my y's doing as I go up for the x's? They're going up. So is it still increasing or decreasing? So that's still increasing, but very, very, very what? Slowly. So you're going to find this out in the graphs. If an exponential is increasing and it's concave up, when you invert it, it's increasing, but it's concave down. What does that mean? Increasing at a decreasing rate. And I just want to get to it. And I don't know if it quite shows out in that extrapolation they're trying to show there. You'd have to see the average rate of changes between a couple sets of points to see that the slopes are getting smaller as you move left to right on the logarithm. The slopes are getting bigger on the exponential as you move left to right. That's what it means to be an increasing rate. Okay, so what's this? Concave up or down? Come on, concave up or down? Up. Is it increasing or decreasing? Decreasing. Okay, so that's decreasing at an increasing rate. I almost said the wrong thing. Concave up or down? Down. Increasing or decreasing? Increasing at a decreasing rate. And then input, say it. This one, oh, guess what we have? We have a y-axis reflection and an x-axis reflection. We will see that with 3 simple points. The first one would be not 0, so I still have an asymptote at 0 because I have no right-left shifts yet. And then, well, log base 6. I can't plug in 6. I have to plug in -6. Actually, that's wrong. What do I want to plug in first? -1. I want to get that 0 power number. What's log base 6 of -1, which is log base 6 of 1? 0 times -4. 0. There's the y-axis reflection. Was that the first bell? No, I'm just hearing bells in my head. That's good. What's log base 6 of -6? 1. What's 1 times -4? See if you and I really get mad at people that don't answer the questions. Like this is what happened in first hour as well. I'm going through brand new notes. Now all of a sudden an A-beer just is doing this. And then all of a sudden they just get up. This is during the notes and they're just like this. Oh, sorry, I might show the kids, so I have to stay over here. And I'm still teaching and I stopped and I'm just looking. It's over here. Gets paper, wipes his nose, looking at these posters over here, and then goes back to his seat during the notes. During the notes. During the notes. I don't want to show any kids. I don't want to get sued. You showed me on a video. Anyway. So I appreciate that you answer the questions. Thank you. That was the point of that. What's log base 6 of -1/6? Log base 6 of 1/6 is -1. -1 times -4 is 4. So -1/6, comma 4. -6, comma -4. That's enough. I know it's doing this. I think 3 points are enough. And I think that's what we're going to ask you when we ask for points to prove that you know what you're graphing. All right. Okay, so concave up or down? Sorry, up, right? And then what's the increasing or decreasing? Increasing. Certainly increasing at a very increasing rate, right? Right. Okay. Okay, here we go. Input, output. Let's make this fast. All right, what's this transformation? I guess we have to do this. Isn't that horizontal or vertical? Horizontal or vertical? Vertical. What the heck was that? All right, so vertical, stretch or shrink? if you just say vertical dilation by 2, that means stretch. And I think that's how AP uses their language all the time. They really do. But you can say stretch and not get marked wrong, I believe. It should be. All right, now what number am I plugging in first? 1. Okay. And I can really get a very fast sketch on this. What's log base 3 of 1? 0 times 2. There's your typical 1, 0 points. All right, and then 3. Why 3? Because it's log base 3. What's log base 3 of 3? 1. What's 1 times 2? 2. So 3, comma 2. And then what's log base 3 of 9? What's log base 3 of 9? 2. What's 2 times 2? 4. And then 9, you get it. So it's very slowly 9 comma 4 is like way out here. All right, and then just humor me on a couple more, like 1/3, 1/9, right? What's log base 3 of 1/3? -1. -1 times 2 is -2. Log base 3 of 1/9 is -2. -2 times -2 is -4. But that's the point. 1/3, even 1/9, comma -4. It's not even really that, but it is starting to get, we could go forever on this. We could go 1/27th, 1/81st. We could do this forever and ever, get closer and closer and closer to 0, and just get ginormous negative numbers, which is a bad way to say it, but I don't care. All right. So anyway, I don't know if there's anything else. Oh, domain and range. Okay. So then we know that the domain is, I almost made a bracket. I did the same mistake last hour. Not a bracket because never 0, but the range is always all real numbers. Hey, remember domain and range exchange? The domain of an exponential is all real numbers, and the range is 0 to infinity without any shifts up, down, right, left. Okay? So, blah, 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 blah. All right. We have an x-axis reflection, a vertical stretch, and we go right 3. I don't feel like writing it. Right? Vinny, are you falling asleep on me? I'll tell your mom. All right, anyway. Okay, so can I plug in 3? No. What do I get when I plug in 3? I like throwing this up above. What do I get? You can't take 2 to a power and get 0. So that's where my vertical asymptote is. That's why it's 3 right. So I choose to go a little bit off there and know that this happens. So I'm going to plug in 4. And why would I plug in 4? Because 4 minus 3 is 1. You're looking for that 1 in there. What's log base 2 of 1? 0, because 2 to the 0 is equal to 1. 0 times -5 is 0. So there's the right 3. Instead of 1, 0, it's 4, 0. Got it. All right, now we got the flips and the stretches. Ooh, log base 2. That's not hard. So is 5 good? Yeah. Because what's 5 minus 3? What's log base 2 of 2? 1 times -5. So that should be enough for 5, comma, -5. 1, 2, 3, 4, 5. All right, just humor me. Oh, what do I have to do on this one? I need a half on the inside. So I need 3.5. What's 3.5 minus 3? Half. What's log base 2 of a half? This is why you answer questions. Those that don't, licking the walls, you haven't done it all year long. This is why you struggle. You don't follow along with what I'm doing. And it makes me mad. All right? So log base 2 of a half is -1. -1 times -5 is 5. You're your own worst enemy. You are the cause of your own destruction. Did I say good morning today? I feel like I'm being a little tense today. Is everyone okay? All right. So 3.5, comma 5. 2, 3, 4, 5. See, I said good morning. Wait. Wrong! Wrong again. Good afternoon. Wrong, Mr. Samuelis. It's afternoon. Cancel them. Never win. All right. And then domain is 3 to infinity. And the range is all real numbers. Oh, this is weird. Transformations, vertical stretch, but wait a minute. This is not the way I like it. By the way, what's the base on this logarithm? What's the base on this logarithm? 10 See? So then what are my what this is a vertical stretch by 8s. What is this? A horizontal shrink, or say a horizontal dilation by what? A half. You have to say the number a half. So that means it's pulled towards. All right? And then what's the plus 1? 1 to the left. You're right. I must win. I want to put this in a good spot. Oh boy, what a day! Oh, what a day! What a lovely day! Do you know that one? What movie that's from? You might have a movie you have to watch. I can't believe they didn't show you. Do you ever see Mad Max Fury Road? That is a must watch. Anyone ever see that movie? You guys make me sick. That movie is awesome. That is so great. That's you need to watch this when the apocalypse hits. I'm sorry. That's what the movie's about, the apocalypse and the remnants of humanity after. Okay, so what do I plug in first as I scared the children? What do I plug in first? Not 0, because this is log base 10. Oh no, do we have to think about fractions? I need that get to be 1 on the inside. Oh. So anyone? I'll wait. What would I plug in for x to get 1 on the inside? Negative is correct. Half. Negative half. Whoa. Negative half of 2 is -1. -1 plus 2 is 1. What's log base 2 of 1? Everyone should answer that question. Or what's log base 10 of 1? What's 0 times 8? See what I mean here? There's our horizontal shrink. This is supposed to be 1 away. Now it's half away. It's got pulled towards the y-axis. Well, the asymptote got moved, so it's acting like the y-axis. And then you know what? Now we can think about some numbers. Like, how do I get this to be 10? What would I plug in for x? This is very simple questions I'm asking. What would I plug in for x to get 10 in there? What? Am I in first hour again? Do I have to crawl in a corner? 2 times 4 is 8, everyone, and then 8 plus 2 is 10. He's so mean. I want you to answer questions, then I'll be done. Did the bell ring yet? Log base 10 of 10 is 1. 1 times 8 is 8, right? 4 comma 8. 1, 2, 3. Did I do that right? I felt like I went too fast. No, log base 10 of 10, yeah, is 1. And then 1 times 8 is 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. I'm already bored. All right? That should be enough, but I'll do one more. Oh, no. I need a 1/10 in there. I don't even think I did this in the other class. Do we really want to go into that? No. But you know what we could do? How do I get 100 out of this? Let's do like one more point. How do I get 100 out of that? What do I plug in? 49. 2 times 49 is 98. 98 plus 2 is 100. What's log base 10 of 100? 2 times 8 is 16. 49 comma 16, that's way out here. 16's kind of, 49, and then 16's kind of up there. Here's what we got. We got this sucker. Nice graph. I like that. Thank you. You're welcome. Who's he talking to? All right. Domain and range is -1 to infinity. And range. Let's just end this. Oh,